Good afternoon, folks. Gord Cooke, welcome to our Critical Canadian Building Science webinar series sponsored by Enbridge. We'll just take a minute or two, let a few other folks get on. So we'll just wait a minute or two until Stacy gets impatient and says we got to get started. But I will say welcome to our guest, Strat Padazis from Air Solutions, Jason Rende from Building Knowledge Canada, and most important, well, not most importantly, but importantly, Michelle from Enbridge. How are you, Michelle?
I'm great, Gord. Thank you.
Or is it snowy where you are?
Very, yes.
It's been a interesting day. I mean, it's not that bad, right? We are Canadians.
Yeah. It's December.
Yeah. I am lamenting that I didn't get my Christmas decorations done, though.
Shoulda, woulda, coulda.
Yeah. Day late and a dollar short, my dad would say. And again, we'll just welcome folks. We'll just wait another minute or so.
These are good numbers. Gord, you can go ahead.
Okay, great. How many? Well, thank you. So again, welcome folks to our Critical Canadian Building Science webinar series that we've been so pleased to put on in 2024. We are thinking about next year's. So if you have any interesting ideas as to what you'd like us to chat about next year, please let us know. But we will be announcing that list of webinars for next year shortly. But many of you, I've seen the names before, and it's encouraging to see folks back again. Hopefully we're bringing some value. This particular session is regarding building code. It's highlighting Ontario Building Code 2024, but still a good opportunity to talk about NBC 2020, so across the country, and then just to highlight ventilation requirements in general in houses. It's just always kind of good to have a look at what's happening with respect to ventilation requirements in the code and in houses. And so our agenda for today, as always, we'll do some introductions. We always like to give Enbridge a little chance to talk about some of the interesting things that are going on in their world these days. And then we'll spend the bulk of the time overviewing ventilation requirements in the Canadian standard CSA F326, which is newly updated, the NBC 2020, 2024, and the OBC 2024 as well. And identifying the important changes for builders and HVAC partners, such as their designers and contractors, and always with an eye to opportunities for better performance and rationalized costs, which I think Strat can speak to a bit. We always like to be done on time at 3:30, which means by about 2:10, 2:15, we'll get to your questions, any questions that you have. And Stacy will help us with some of the housekeeping elements in a second, and that'll give us a sense of where best to apply those chats. But I would like to introduce, while she doesn't need an introduction because she's been with us many times before, but Michelle Nicotin from the residential new construction advisor for Enbridge. Michelle, welcome.
Thanks, Gord, and hello, everybody. I'm really excited to be a part of today's session. If Stacy can start my slides there, that'd be wonderful. Perfect. That's great. So at Enbridge, we always like to start today's sessions by acknowledging that the land on which we gather is the traditional and historical lands of the original people of Turtle Island, who have been the caretaker of these lands since the time immemorial. Today, we are gathering place as home to many First Nation, Métis, and Inuit people, and our acknowledgement of this reminds us that our great standard of living is directly related to the resources of the relationship to Indigenous people, and we have a responsibility to honor that.
And thank you.
Wonderful.
Yeah, and just recently, Michelle, I spoke at the First Nations Building Officials Conference, and boy, those folks are doing great work across the country. They're showing some really cool stuff, new technologies to help with inspections in houses and remote communities. So thanks for that acknowledgement. I appreciate that.
Wonderful. So I just want to take 2 minutes of the time to jump on here and just talk about some of the new programs that we actually have for new home builders within Ontario and the Enbridge operating area. So the first one that I'm going to jump on about is the Energy Star for new homes. So this is a market transformation program. It has the goal of boosting the market penetration of Energy Star or equivalent in the areas that have historical low take-up. The joy of this program is that it's offered throughout most of Ontario. There are certain municipalities that have to have approval. So the best thing to do is, if this is something of interest, if you're building to that Energy Star or equivalent or close to it, and you just need to know a little bit more of how to get to that level, you can reach out to your regional builders reps to confirm if the municipality you're building in is can qualify. The equivalent to the Energy Star is 20% over building code, as demonstrated via an energy modeling or blower door test, etc. And the funny thing about this program is that you don't have to be on natural gas to enjoy it. So we're just helping people learn how to build a little bit of a better standard home, and then you get incentives for that of $1,650, for up to 50 homes built in 2025. So I think you'll probably be sharing this presentation after.
Yes.
What I'll do is I'll send over to Stacey our one pager of who's who in the zoo when it comes to Enbridge, and you can reach out to your local rep of wherever you're building for. So great program to be a part of.
It's kind of an interesting number. 1650 is kind of a specific number, but it's pretty
It
helpful.
is. Yes, absolutely. It's supposed to help to offset any of the costs that maybe just to get you to that next level. And with building code changes and whatnot, I think it's a great opportunity to take up on that offer, but to get to that level. So the next program that I'm going to actually tell you about is also along the same lines, but this is our Net Zero Energy Ready program. So this one is to build a discovery home located in the Enbridge gas service area. Again, the use of natural gas is not a requirement to participate in this program. The program must be kind of in a pre-designed stage. And also the builder cannot have already previously labeled a net zero or net zero ready home. So this is again for those builders that are kind of toying with that idea of maybe getting to that level and just want a little bit of extra help. You get the $15,000 to offset those upgraded costs, and plus you also get money value in all the training that you receive from your energy evaluator as well. The caveat to it is that you have to be a part of a CHBA, because that is obviously who labels the homes at the end of the once the house is built. But again, you can just reach out to your local rep that you'll receive on that form to ask the questions. And this one is a first come, first serve for the program. We only allow a certain amount of builders to go through this program. So again, it's just reach out and ask the questions if you have any. So those are the two that we have for 2025. Again, really excited to do this. A lot of Gord's team is very familiar with these programs. So yeah, ask all the questions if you have them. And that's it for me.
And thanks so much, Michelle.
Thank you.
The support that Enbridge brings. Of course, as you mentioned, we've been involved in these, and the builders that we've worked with have just been so appreciative of Enbridge's involvement and just supporting their efforts to be more efficient. So I love that. And as you say, everybody will get access to a copy of this presentation, and which will include information from Enbridge on how to get in touch. So thanks very much for that.
Okay.
And then Stacey, did you want to go over the housekeeping rules, or do you want me to do that?
Yeah, you go ahead, Gord. I'll just be typing in the chat box as you're talking.
Thanks. So we always ask that you put your questions. You're welcome to put things in the chat, but questions specifically, put them in the Q&A. That allows us to track them and make sure they're answered correctly and followed up on. And then, of course, be considerate, thoughtful, and respectful. I don't think we've had any problems in our chat over the sessions, but just be respectful of the time of year, specifically because naughty or nice, you want to make sure you're in the right camp there. We are ready to help with any technical concerns, both Emma and Stacey on the call. If you're having troubles at all, please let us know. This webinar is recorded, so and it's be available to you after the presentation. And please complete the survey monkey following the presentation. As I say, we are just working on our 2025 agenda, so it's always good for us to get feedback as to what worked, what didn't. And I've mentioned already the links, the presentation materials all be sent out to attendees following the webinar. Closed captioning is enabled if you require a live transcript while we're speaking. It's between record and reactions at the bottom of most of your screens. So look for that if that is helpful to you. And then we always like to run a couple of polls. The first one being where you're from. So if you could go ahead and enact that poll or put that poll up, thank you. But he's really quick at this now, quick on the draw. First of all, thank you for 157 people joining us. That's wonderful. I really appreciate that. From, looks like, pretty much across the country. Should we close it off at 80% participation rate? Let's close that one off. And we are most in Ontario, but thank you for British Columbia and Alberta, Manitoba joining in. I really appreciate that. We got snow here, guys, today, so we can claim we're Canadians finally. So that's good. And then Stacy, if you want to run the next one. So we always like to know your occupation. That is what keeps you busy on any particular day. Trying to get back up to that same 127 people. Close. Good split there. Thank you for that. Great. So we'll end that one and share the results. I don't know if I can see, perhaps you can tell me down at the bottom, do we have HVAC contractors at all?
Yep, they're under the contractor designer, and then I noticed some people will be putting in the chat their specific designer.
Okay. Anybody with interesting occupations there?
Not that I can see yet. I'm sure they're just gonna put those in soon.
I'll tell a quick story. When we do our training down at CI Live in Denver, and I would encourage people to look that up, construction instruction, we always ask people outside of work, what do they do? And so far, the favorite that we have is a builder out of the Seattle, Washington market, who in his spare time is a professional rodeo clown. He's a very interesting fellow to begin with. And then to think that he's in his spare time does rodeo clowning is pretty cool.
That's unique.
Yeah, very unique, exactly. So thank you all for that. I really appreciate that. And so hopefully we can bring you some value today, Strat. That'll give you a good idea who's on the call and the kinds of things that we can help with. Let's see if I can.
Thank you.
I need to get rid of that. How do I get rid of that? Why can't I get off of there? Oh, there we go. I gotta can't seem to. All right. So oh, my apologies. I just gotta stop for a sec. Go again. Great. And I'll just introduce our guest, Strat Padazis. He's the president managing partner of Air Solutions Inc., a mechanical engineering technologist by vocation. Strat, you've been running at Air Solutions for 30 years, and Air Solutions is an agency who's done a really nice job of introducing new technologies. You can just give us a couple of seconds of your time, Strat, as to what have you been working on these days?
Yeah, it's really about getting ready for 2025. We've had, like everybody, we've had a lot of growth over the last few years. Code changes are exciting. It gives us opportunities to get in front of people and do education. And so, yeah, we're excited about what's up ahead of us here.
Great. And Strat, Air Solutions represents the interests of technical interests of brands like Broan and Venmar Van, but also Fujitsu and Navion.
Navion, yep, Thermoflex.
RIA. Yeah, right, RIA. So just a good technical firm. So I just thanks for being involved and giving us your.
Thank you.
You've been working on ventilation for 30 years, so you should be able to bring some value to this particular session. Second, pleased to introduce Jason Rende. Many of you may have met him on other sessions that we've done. Jason is a colleague here at Building Knowledge Canada, with a very strong expertise in HVAC design. Jason, just if you wouldn't mind saying hello.
Hello.
Anything of interest to you, Jason, that you've been working on recently?
We've been working on a lot of RIA HVAC designs. For those that don't know, RIA is a design and installation process and materials out of the US, but it's basically an adaptation of radial type duct systems where supply branches are taken straight from the plenum and brought directly to the rooms instead of trunks and branches. We've had a lot of uptake from builders wanting to implement this system into their builds, and I've been designing them for the past 2 years with seemingly no end in sight.
Thank you. And that was one of the topics that we did on the Enbridge webinar series. It was either beginning of the year or late last year. And then, Jason, you've been working pretty hard on reviewing the HVAC implications of both the National Building Code and then the Ontario version of that National Building Code, and you'll be able to bring us that perspective today. So thank you for that. So we'll dive in. There's me. You don't need to hear about me, but been at this for, in fact, this month was 38 years when we first started the company, 38 years ago. Wow. This week, actually. So that was kind of cool. And so thank you all for everybody's support over those years. It's been a lot of fun and continues to be fun. So we'll go from there. So I'll just reiterate that we're going to talk about ventilation in the code, new updates for ventilation in the OBC and the NBC. For those of you from across the country, there have been a couple of modifications to the code that you're going to be interested in, and then highlighting the need for ventilation in general is of interest. And I do want to start with highlighting differences in the new CSA F326 standard, the new 2023 version, if you will. Pretty interesting, that standard that I was involved with back in 1990 was supposed to get looked at along the way. It really didn't. So this recent update has been pretty valuable. And so for everybody across the country, the first few slides will cover the changes in F326. So we'll chat about that, and we'll talk about the NBC and the OBC as we move through this, and the implications, let's say, for builders, contractors, suppliers, and so on. So I want to start with, if it's okay with you folks, so start with the CSA standard, which is the base for building codes. That is, in many cases, the building code will just say, here's the standard, work towards that. In the case of ventilation, the building codes, both the Ontario, BC, and the National Building Code have felt the need to have a specific section on ventilation, 932, and pretty wide-ranging prescriptive requirements. But I just want you to be aware that they're all based on the F326. They're all consistent with, and F326 is referenced in Part 6 of the code. So anywhere in the country, if you didn't like the 932 parts of the ventilation requirements of the code, you could always revert over to F326. And I'm just showing you that it's recently updated after more than 25 years. It is consistent with ASHRAE, American Society of Heating, Refrigeration, Air Conditioning Engineers, standard 62.2, which is considered the international standard, if you will. That is most of the international requirements. I was just talking to folks from New Zealand, and they were aware of ASHRAE 62.2 and using it as the base for their ventilation. And it is, as I mentioned, the basis for ventilation in all provincial codes and specifically the National Building Code. So you have in the National Building Code, all provincial codes, it always says in Part 932, which is the ventilation section in the housing section of the code, 932, it always referenced and said you're allowed to revert back to Part 6, and they mention F326 as the good practice design manual. So I would say it can be used by HVAC designers anywhere instead of Part 932. Jason, maybe I'll put you on the spot here. Have you reverted back? Did you find a use in, rather than 932 sections, are there circumstances where you would use F326 as opposed to 932?
Personally, I would use it in situations where there's fully ducted HRVs or ERVs being proposed. because there is a bit more direction in 326 about how to account for principal and total ventilation in those applications.
Great, that's good, a good example, thank you. And what we'd say to you, it is the most comprehensive and flexible in terms of approaches, so don't be shy about using it is really the point. And you shouldn't have any problems if you simply said to a building official, I'm submitting my HVAC design, specifically the ventilation portion in accordance with F326, as opposed to specific requirements, prescriptive requirements in 932. And I just thought I'd give you, I've highlighted there at the top left, the year 23, that is the latest version of this code, and a few highlights to it. One, they've updated the kitchen exhaust requirements because there's wide-ranging research now that would say what's happening in your kitchen, what's happening specifically off the top of your stove, the range, is the most important IAQ, indoor air quality event of the day. So we should do a little better job of managing the pollutants that are coming off of kitchen range hoods. And so F326 has better guidance around that, including mentions of, or at least provisions for, what's called particulate matter 2.5. That is PM 2.5 micron size of particulates that we know get deep into the lungs. So the F326 was mindful of that. The committee that wrote the standard or rewrote the standard was mindful of the need for more care over that kitchen range. So be careful, or at least be conscious of that and use those requirements. Second, it's more of a lateral move, but F326 used to concern itself with depressurization limits and requirements, that is worrying about houses going under negative pressure with the very appliance I just spoke of, a large kitchen exhaust. That has now been moved over to well, I'll call it a new standard. It's a new revised standard. It always did exist. It was mainly for existing houses, but a standard called F300, residential depressurization. And that's a conversation for another day, but it helps us with things like makeup, air, and so on. By all means, if you have questions about that, happy to answer them, but it's not in F326 anymore. What F326 also does is it's given a little simplification of flow rate calculation, a little more clarity. It does require minimum filtration, MERV6, minimum efficiency reporting value for filtration on supply systems, which means, and Strat will talk about it later, what that means for your choices with respect to ventilation equipment. And there is now stronger mentioning of the word of verification of performance, either by design or by measurement, but just a little added wording around making sure the system does what it was designed to do. So either a very rigorous design and attestation that the design will work, or actual performance measurements in the field. It also provides, lastly, more flexibility for system inlet and outlet locations, and we'll show you that in just a little bit. One of the things that is fairly clear is you can't really cherry pick. It's not fair to cherry pick and say, oh, I like that requirement, but I don't like that one, so I'll use F326 for that. I won't use 932, or I'll use 932 for this or that. Once you've chosen to do a design under F326, then you should stick with that, with the requirements of F326. And that puts a little bit of burden. That means you have to, and I'll show a couple of we will show a couple of examples of that as we go through this particular presentation. So that's F326, again, referenced in code. I want to switch the conversation then, move the conversation towards specifically towards an OBC conversation, the harmonization, and frankly, of all provincial codes. Folks in BC will know that there's an interest in moving. All provinces said they're going to harmonize to the National Building Code, so presumably all provinces will adopt the ventilation requirements of the National Building Code 2020 that you're seeing here. The OBC is now considered to be 80% harmonized with the National Building Code, and that it comes into effect in 2025, as you're seeing there below. But I will mention there is that major difference, and it has some implications with ventilation. The one thing that Ontario did not adopt was the energy efficiency requirements in the National Building Code 9 936, section 936. Ontario has chosen, at least for now, to keep the energy efficiency requirements under SB 12, Supplementary Standard for Energy Efficiency. This does affect the selection of HRVs, because in the National Building Code, HRVs and ERVs are not mandatory under the prescriptive requirements. In the Ontario Building Code, SB 12, they are a requirement. So you're going to see a slight interest in that, or difference in that as we move through this particular session. As I mentioned, the new OBC 2024 comes into effect, permits after January 1st, 2025. I will say this to you, there are many differences in section 932 of the existing Ontario Building Code, 2012 Building Code, and the new OBC 2024. But you're going to say, and I think Jason's going to agree with me, your ventilation choices are going to be about the same. So there's lots of differences in wording. It may initially look at, oh my goodness, it's changed completely, but the ventilation choices will be about the same. It's actually true. I know the BC Building Code pretty well, the ventilation code. Even there, the National Building Code is significantly different than the BC in terms of 932 requirements, the ventilation section, but you're not going to find your ventilation systems will change that much. They're going to be pretty similar. I will also mention that there are two specific significant differences between section 932 of the new Ontario Building Code 2024 versus the NBC 2020. So Ontario was harmonized, except there's two phrases in the ventilation section that are not harmonized. So I'll highlight those immediately, and then we'll move on to the differences from the 2012 code as well. So let's get started. Jason was kind enough to provide this link and reminded me that building codes can now be accessed online. There's a great link. That used to be you had to have the paper copy, or at least I felt you had to have it. And now you can access on a real-time basis. So it's pretty useful. You've got that link there. So thanks for that. And so I wanted to highlight, first of all, the differences between the National Building Code 2020 and the OBC. That is the two phrases that I spoke of that are different. And here's the first of those phrases. The National Building Code 932 section, item 4 there at the bottom, clause 4, systems used for ventilation shall conform to the energy efficiency requirements in section 936. The Ontario Building Code version 2024 does not have a 936, so it does not appear in the Ontario Building Code. So in the Ontario Building Code 2024, the SB 12 HRVs are mandatory in the prescriptive paths for energy efficiency. And HRVs are not mandatory in NBC 2020, which again you might say, well, that's not going to create any differences. There's a couple of unique circumstances where you're going to find that perhaps of interest. So that was the first big difference. The second big difference is that OBC 2024 has different requirements for carbon monoxide alarms. I don't know that I would say they're looser or more strict or less strict. They're just different. There is a distinction made for houses in the OBC that don't have fuel-fired appliances nor attached garages to those requirements. So we're talking mainly ventilation differences today, but I would encourage you to look for those differences, if you will, as to the location of those. So important to show that particular slide, and then for you to work with your local fire officials to determine what that might mean in the new code. So keep that in mind. Now I want to move to the more significant differences, which is the existing Ontario Building Code 2012 and the National Building Code 2020, and therefore the Ontario Building Code 2024. And the first significant difference is it's been reorganized. It's has different wording. It matches the National Building Code requirements that speak about non-heating heating season ventilation and heating season mechanical ventilation. It talks about natural ventilation that can be used for summer. Mechanical ventilation is required in winter. But the new wording actually will have very little impact on the actual design and installation of the equipment. So again, it's going to look different. You're going to, maybe a local building official is going to read through and go, oh my goodness, this is totally different. But in terms of actual application, you're not going to find much difference. There is a focus though on heating season mechanical ventilation, recognizing that windows are an acceptable way to ventilate, but in heating season, you do need mechanical ventilation. That tends to be the focus on in the newest wording, if you will. The second big difference is Ontario, because of, imagine when the Ontario Building Code around ventilation was added in 1990, when we still had low efficiency furnaces and mid efficiency furnaces with B vents. Now things have changed pretty significantly. The National Building Code took out the requirements, and therefore the Ontario Building Code has taken out the requirements for B vented appliances, where you had to switch to Part 6 of the code. The National Building Code looks after all of that, and therefore the Ontario Building Code now looks after all of that within 932. So even if you've got a B vented appliance, which there's basically none left anyway, you could still do it under 932. You didn't have to switch to F326. So again, in practice, this isn't going to mean much difference because virtually all of you are doing direct vent, sealed combustion, water heaters, furnaces, fireplaces, and even in solid fuel fired appliances, you can still do those under section 932.3 of the code. You don't have to go to F326. So it looks like a significant difference, but in practice, it's not going to be a big difference in terms of selection of equipment. The third one, and here's where we are getting to, I would say significant difference, and that is in the calculation of the ventilation amount. In the existing Ontario Building Code, the 2012 Building Code, it had a ventilation requirement per bedroom. It said at least an amount of a certain amount. The National Building Code and now the Ontario Building Code will talk about a range of ventilation, minimums and maximums. So this is an excerpt from the table. You'll notice a 3-bedroom house showing in liters per second because we're Canadians, so we got to do metric. So this specific amount of ventilation, this range, if you will, and most of you, I'm going to suggest, are going to say it's fine. It's not going to be that big a difference, but it has some implications, and I'll ask Jason to speak to that in just a second. Here is the table showing both liters per second and CFMs, and then I'm going to say I've done my Canadian duty, and I'm going to switch it just to CFMs and ask Jason to comment. And if I'll just introduce you to the table, on the left, number of bedrooms, that is the principal ventilation capacity. Your low speed or continuous ventilation is based on number of bedrooms. And F326, that is the first column or the second column in. I said all codes are based on that. It's showing you the amount of ventilation with a range of plus or minus 10% is exactly what it says. There is the NBC requirement and the OBC requirement, and you'll see that NBC and OBC are aligned. And then on the right, far right, you will see the existing OBC requirements, the 2012 requirements that said at least that amount, but not more than 50% more than that. That is that we always been a concern that we have a low speed ventilation rate that will actually be operated. You don't want to just put in one big system and say, there you go, I've met all the requirements. There is a specific requirement to stay within a range. And Jason, that's where I want to bring you in. What are your thoughts? Is this, what do you think this does? And I've highlighted the example of a 3-bedroom house at 60 CFM. In looking at this, what are your initial thoughts on this?
Well, it may allow for a bit more flexibility in HRV or ERV selection by the designer or the builder, in that they may not have to size an HRV for 64 CFM of principal vent capacity or 64 CFM of low speed capacity. They can do 44 and then still be able to meet the high capacity with the rest of the ERV capacity or ERV fan capacity. So
right.
It provides some flexibility.
Yeah, some flexibility. And you'll notice that within that range, you could do you know, a fairly good, you could do between 2 and 5 bedrooms with effectively the same appliance. That is, if you got to 55 CFM, that you, I guess, at least between 2 and 4 bedrooms. That is, you don't need a specific model for each bedroom type. There's enough flexibility, I think is what Jason's saying, that you can manage that. Strat, though, from an equipment supplier's perspective, is this is familiar to you? Do you think it's going to be a big difference for your folks?
No, not really. I think it just goes back to what Jason said. If it allows you to do a little bit more precise job of selection of equipment, but it doesn't necessarily make huge changes for us.
It does mean by design or field measurement that you have to show that there's one operating mode that gets you in this range. That is, we don't want to provide somebody a 2-bedroom house with a 90 CFM ventilator that can only ventilate at 90 CFM,
Right.
because we know people end up turning them off, right? That's been the history. So we don't want to overventilate. We don't want to underventilate. We don't want to overventilate. And Jason, I suspect as a designer, that puts a little more burden on you to check with the manufacturer. Is that a fair statement?
I'd say so.
Yeah, fair enough. Because you are going to need to see the low speed capacity. Strat, the manufacturers, they typically list their overall capacity. Do you actually list the low speed or the very speed capacity?
Yeah, what you'll see now on the spec sheets is we'll have our low speed and our high speed capability on the equipment. So it'll be as low as this number and as high as this number. And then we'll have specifics with respect to static at certain temperatures, like we always have. But you can see that on the specification sheets, there is a low speed indicated. So
the key on this slide is to say, you need a minimum ventilation rate. There is a requirement for higher exhaust rates, kitchens, bathrooms, and so on. But you have to provide an appliance or a device or a series of devices, could be a series of fans, that will operate at this level and show that either by design. So Jason's going to look at the specifications, say, yes, this appliance will do it on speed 2, for example, of a manufacturer's control. So he would list that in the design, or to show in the field that you've adjusted the flows such that there is an operating mode for the homeowner that runs in this range. Any final comments before I move on that one? No, good enough. So that was a difference. A significant difference number 4 is the requirements for the supply air to be delivered at a reasonable temperature, specifically if the supply air is delivered into the return air of the furnace. This is 2 key words here that are different from National Building Code and the existing Ontario Building Code. So the new requirements are going to read, and I've shown an actual excerpt there. The operation ventilation system must be interlocked to bring on the furnace recirculation fans. That is, if you're using the furnace or air handler to distribute the fresh air, it has to be interlocked. That's not a requirement at the moment in the Ontario Building Code. It's a requirement in the Energy Star program. It's a requirement in the Net Zero program. It hasn't been a requirement up till now. It used to be able to just put a switch, a circulation switch beside the ventilation switch. Now it actually has to be interlocked. And again, this is in 932. If you didn't want to interlock, you might look for other choices in CSA F326, but it needs to be interlocked. And you need to show either by design, at first by design, that the mixed air temperature must be at least 15 degrees Celsius or something approved by the furnace manufacturer. And there are manufacturers who say, hey, we can go lower than that. 15 Celsius, roughly 60 Fahrenheit. Typically, this isn't a problem with when you're using HRVs because it's starting off with a much warmer temperature. So it's typically not a concern, but there is a requirement in Clause 10 to verify the supply airflow rates in field measurements. So within the newest Ontario Building Code, there is this requirement. If you're dumping the fresh air into the furnace return and interlocking it, you have to verify the supply airflow rates. Why? To ensure that you don't have too much air coming in that might freeze the heat exchanger. So this is a surrogate measurement for figuring out the mixed air temperature, and they're saying you got to verify the supply airflow rates. I'll ask Strat to speak to that a little bit later, but this is a bit of a departure, a little added burden for builders and their HVAC contractor to say, I got to get it interlocked, and then I got to verify the flows to make sure that I'm not overburdening the temperature across the heat exchanger of the furnace. Next, quite a significant difference in that, significant in wording, may not be a big difference in actual application, but now supplemental exhaust flow rates are specified. That is in the current Ontario building code. You had to put an exhaust outlet or a fan in the kitchen and in each bathroom, but you didn't have to have any particular specified flow rate. Now, in the newest code and in the National Building Code, you have to have a fan or an inlet with at least 50 liters per second, 100 CFM, or each bathroom requires a fan not less than 50 CFM. Now, if you're using an HRV for that, the requirements are different. But if you don't have an outlet, that is, you're doing a simplified system in and out of the furnace return for your principal ventilation, then you have to show specific requirements. This has to be a design capacity. It doesn't have to be measured, but you have to show by design that you can get there. That's still a bit of a burden, I would say, having done Tarion inspections. Once you've said 50 CFM in design, somebody's going to ask you to measure it, at least in a warranty complaint. So it does create a little bit of an extra burden. And Strat, you'll make note of that and respond to that when I ask you to show some of the equipment that's available, if you wouldn't mind. So that's great. Next is makeup air requirements. And I mentioned that new standard F300. So that's interesting because it's now referenced in F326. But the OBC does have specific requirements to match any and all exhaust, other than the principal, match any of the all exhaust fans in houses with any naturally aspirated fired appliances, fuel fired appliances, except for solid fuel. So again, you're kind of off the hook. As long as you're not putting in a B-vent appliance, which is tough to do these days anyway, even with a wood burning appliance, you can still do this under 932 of the code, but there's a little more interest in makeup air, and I would say a little more definition of makeup air. I know lots of builders have expressed concerns about this. I just had, I don't think they'll mind me mentioning, Rinaldi Homes down in St. Catharines area had a problem with a large range hood and wondering what the actual rules were, and that's all about makeup air requirements. So a little better definition, I would say, in the code with respect to that. And then here's one that I will ask both Jason and Strat to work on. And I happen to know the history of this. When HRVs and ERVs were first introduced into the Ontario Building Code, we needed a definition as to what an HRV and an ERV actually was, and we needed a minimum performance criteria to make sure we were getting what we wanted. And the industry at that time in Ontario said, you know, a really good judge of whether an HRV works in cold weather is if it can get at least a 55% efficiency at really cold temperatures, -25. It wasn't so much an efficiency requirement as it was a durability requirement to make sure that the equipment would actually work in cold weather. So the Ontario Building Code in 1990, that's what the phrase said. The National Building Code treated it differently and said, well, I don't want an efficiency requirement. I just want to make sure the appliance continues to ventilate. So they put a different number in their code, in their phrasing. They used what's called the low temperature ventilation reduction factor of not less than, the code wording actually says not less than 50%. In other words, the equipment will keep ventilating at least 50% of its flow, even at very cold temperatures. That phrase is now in the Ontario Building Code. So instead of having to choose a piece of equipment that's over 55% at -25, you now only need to choose a piece of equipment that keeps ventilating at least 50% of its rate. There is a bit of a technical in red there you're seeing, and I've already flagged this. We've already spoken to the ministry about this. There's a bit of a problem in the wording. because since the National Building Code clause was written, HVI, the Home Ventilating Institute, has changed the way they define low temperature ventilation reduction factor. So now the code has to be adjusted. Because right now it says not less than 50%, and it should read not more than 50%. So there's just been a little bit of a change, and that we think will get done before the code gets enacted, but just something to watch where I don't want to confuse folks. But let's talk about this a little bit. This does create a bit of a difference in terms of design. Strat, the equipment that you currently have would meet this requirement, presumably, but does it provide any other opportunities for builders?
Well, it does. It allows for more what I'll call a non-traditional manufacturer in our market to enter the market, and so that there's good and bad in that. For us, what we like about it, there's been some other product lines from a ventilation standpoint developed for condo markets, for example, that now we could use in residential applications under the OBC. Whereas prior to that, they weren't eligible because they didn't quite meet the 55% at -25. Great product, reliable and all of that, but they just didn't quite meet this one efficiency standard. So it allows us now to kind of open up the door and allow for more product to come into the market. And us personally as Brown reps, it allows us to take some of these commercial product lines and effectively use them in residential applications where there's small mechanical rooms.
Thank you. Jason, have you noticed any over the years in your designs, a piece of equipment that wouldn't have met the 55, but now you'd have to check again to see if they meet the ventilation requirement?
To be honest, generally no. Generally, I'll spec a piece of equipment that does meet the 55 or greater. But
Okay.
but I know for certain non-traditional builds like tiny homes, it can be a challenge to find units that one will fit into very small mechanical areas that are provided in these houses and still be able to meet those efficiencies. So,
and I will mention by name the Passivhaus products out of Germany, because the Passivhaus program has a very specific requirement about not restricting flows at cold temperatures. They've always used a preheat strategy. HRVs from those markets have always used preheat strategies, which knocked the socks out of the efficiency. They weren't great for efficiency, but they kept ventilating really well. And these products would now qualify under this new requirement. So I think it provides an opportunity. And obviously, we would still pick equipment that's really efficient. But at the same time, the wording now would say, as long as it keeps ventilating, we're less worried about its efficiency than we are with its ventilation requirements. And so just to highlight that, you're going to say, where do I find that? Well, I went and did a screenshot of just to find ones that fit and ones that don't fit. This is hvi.org. There's the reference. Go to the product directory listings, open up the detailed reports. I've hidden a whole bunch of columns, so you're going to have to flip over to the right side. But notice that LTVF, low temperature ventilation reduction factor. Notice as you go down the list, I think I've got one on there oops, sorry. My apologies. Go back one. You'll notice one there that wouldn't meet, that said 50%, 55%, which means it wouldn't meet. They'd need to be under that 50%. And so just thinking about looking at different models, and this is always at -25. So it's a different report that designers and HVAC contractors and distributors and manufacturers are going to have to play with a little bit. This has been a code requirement across the country in anybody who had the National Building Code. So others in other markets may have already looked at this. Ontario designers will have to start looking at this. So keep that in mind. Our eighth, and I think second last, before I ask Strat to help us with some of the equipment selections, is just a little bit on duct sizing and design. The National Building Code, and therefore the new Ontario Building Code, has a pretty comprehensive prescriptive set of duct tables and charts, how to size ductwork. A big table that says if more than this length and if this more than this amount of air, you're going to need this size of duct. I think, Jason, you would say you are a qualified designer of duct systems. You would do your duct designs under the HII digest rules rather than using the prescriptive requirements. Is that a fair statement? Just help
Correct.
understand that. Would you say you end up with more cost effective or at least more appropriate sizing?
It's generally, yes, more appropriate. I don't think there's too much difference. I believe the code tends to be a bit more conservative, so you might end up with somewhat larger ductwork than you would expect, but doing it as per the HVAC digest would still give you a proper size.
I think that's important, as you say, smaller houses, suites and so on, tiny homes. Well, you're talking about really low flows. You'd hate to be stuck with large duct sizes. So I would just say to all designers on this call, much like Jason, you don't need to follow 932 duct requirements, because it does say in 932 that you can do a qualified duct design without using the prescriptive requirements. The code hasn't changed. All joints and ventilation ducts do need to be sealed, as are heating ducts similarly. So that's still a requirement. What is also of interest is the existing OBC 2012 had requirements for higher R value of ducts longer than 3 meters. That's no longer the case. That table's been taken out. Strat's going to show us that, or at least he and I'll show you that change. But it does mean you don't have to use, you probably should use higher insulation levels of ducts, but you don't have to based on this particular requirement. Here's one that is going to be a bit of a challenge, I think, because the new Ontario Building Code and the National Building Code has specific requirements that are higher than what the requirements were in the existing Ontario Building Code, and indeed higher than the F326. The National Building Code says a separation of 1,800 millimeters, effectively 6 feet, between exhaust outlets, gas fill pipes, oil fill pipes, and so on, whereas the existing Ontario Building Code was 900 millimeters or 3 feet. So this has a bit of a challenge to it. So we'll have to think about that one. There are also specific requirements about exhaust outlets with respect to soffit and soffit locations. Jason, you and I were working through this when we think about slab on grade, stacked townhouses, how if your exhaust outlets are high wall, then your soffits have to be such that moisture's not getting up into attic spaces. So we talked about, I think you had some suggestions on that.
I want to say there's a chart maybe on the next slide that speaks to it a bit more, but essentially, if it's less than 1,800 millimeters away from the vented soffit, the soffit has to be blocked. So the chart that I'm referring to is in the code, is in 932, and it does dictate how wide of a blocked soffit has to be provided based on how close that duct is to the soffit. So if it's within a foot, I believe has to be about 12 feet worth of blocked soffit. If it's lower than that, then it's got to be a little narrower and narrower and narrower as you get closer to 6 feet or 1,800 millimeters, and then above or further than 1,800, it's nil.
And so for traditional single family home, typically your exhausts were down low on the wall and your soffits were 8 feet above. But you think about a range hood that's up high, a bathroom fan that's up high. The National Building Code has more specific requirements to ensure that moisture, potential moisture, doesn't get in the soffits. That means you're going to have to use some amount of non-vented soffit material. And then somebody might say, but do I have enough attic ventilation? Do I need to put in more gable end, or do I have to have more free area on the rest of my soffit? So it is one to look at. It'll have some practical implications, but you will find the design requirements in F326 to be more flexible. So again, move towards F326 might be the way to go in terms of that particular requirement. And then I wanted to highlight, just before we move on, is this the secondary suite that everybody's been talking about. And specifically, notice this is in 933. This is in the heating section of the code. And clause 3 says air duct distribution systems serving one of a dwelling unit's house with a secondary suite shall not be interconnected with other parts of the house. So you might say, does that imply a separate ventilation system? And Jason, I think you and I would say that's the case. You can't intertwine the duct systems. from one ventilation system to serve 2 dwelling units. So, but then imagine that the current SB12 requirements, the prescriptive path requires HRVs, NBC 936 doesn't. So for those of the rest of the country, you don't have to worry about this as much, because that could mean if you're doing a second suite, you would need a second ERV. Jason, I think that's the way you've interpreted this.
Correct.
And so Strat, what does that mean? Either a really small ERV, for example,
Yeah,
which I'll ask you to speak to in a second,
sure, yeah.
or under performance energy modeling. So there is a bit of an out. SB 12 says prescriptively ERVs are required or HRVs are required. But if you want to performance model the house or the suites, maybe you could do an ERV upstairs. And because it's a small ventilation amount, a small exhaust fan in a secondary suite may be possible. So this is still a little bit on the bubble, might spur some questions, and that's why we'll move on, and perhaps it comes up in the questioning phase. But there are options here. They're a little bit tricky. I think when they decided not to adopt 936 in the Ontario Building Code, they may have missed this little key item that would actually cost builders and have to put in 2 ERVs. But maybe we get around it by doing energy modeling. Is kind of where I'm going with this. But Strat, I'll invite you to pipe in, and some of the equipment options I've highlighted here, some of the brands from the ventilation side. We won't spend much time on that, but
just for the people who don't know who we are.
Yes, exactly. Thank you.
Yeah, but thank you.
Yes.
So it's really about just options, really. At the end of the day, we got to have options for the market. And so real quick, in front of us here, we just see the 4 types of units that we have. There are 2 on the left are what we'll call the slim units. These are units that are typically, as I was chatting about earlier, these are typically units that were developed for the condo market, but we're going to see them play a role in the residential applications. And if we get into the secondary suites and we need smaller pieces of equipment, these will fit in nicely. The 2 units on the right are basically 2 size cabinets that deliver as low as 35 CFM and as high as 230 CFM. So a full range of CFM and installation. So there's availability for top ducts connected off the top or off the side.
So there we go right back to that secondary suite, 1 bedroom. That 35 CFM is still, even with that unit, it's going to meet that need. That's pretty cool.
That's right. Yeah.
So lots of flexibility, more flexibility, I would say, than ever before. And then you were kind enough to some other manufacturers.
Well, yeah, I just, again, everybody has their favorite brand, but essentially the whole market has been doing trending towards smaller pieces of equipment. And when we trend to smaller pieces of equipment, we look to improve those pieces of equipment. So you'll see here a lot of small boxes, a lot of boxes that have good quality motors in them, ECM motors, which are very low from a consumption standpoint. So, the equipment is becoming a little bit more precise with each generation. So lots of options.
Lots of options, specifically that fan technology, right? You've really improved, all the manufacturers really improved the watts per CFM, if you will.
Yeah. So if we think back to our early days when we had our highest efficiency equipment, there was a product I will speak on our behalf as a Vanny and Venmar. We had a unit called the HE, the 1000 HE, and it essentially had 2 cores stacked inside of it. All we were looking at was the sensible effect, like how good is it at gaining temperature? And we were really excited that it was in the range of 88%, but we never looked at electrical consumption. And so call it 10 years ago, the industry started looking, the codes dictated that we start looking at the electrical efficiencies. And every year we see more and more improvement there. And so the latest improvement is we're all kind of using ECM motors, but then you have a range of ECM motors. So motors that are, call it 40% more efficient than our standard PSC motor, but now you have ECM motors that are even 30 or 40% more efficient than a standard ECM motor. So it's been this gradual increase in efficiencies, precision, smaller boxes. It's been good.
It's been very good. I remember those old HE, they were 150 watts just to get you 100 CFM.
Yeah, like a little bar fridge.
Right. And now we'd be more like 20 watts for 100 CFM in that range.
Right.
So reduce the electrical consumption pretty dramatically. And that has an impact on overall energy modeling, for example, programs like Energy Star, the Net Zero Energy Program, all applaud or at least reward not only the core efficiency, but the fan efficacy as well. So thanks for that. And then I asked you specifically to speak to, so how are we going to jam all this secondary suite equipment in?
We all joke about, the bigger the house, the smaller the mechanical room, right? And we've all been on job sites where, it's a 4,000 square foot house and nobody appreciates the work that we do in the mechanical room. And so they always put us in a not the best location and don't give us a lot of square footage. And so what the manufacturers have done, what we've all looked at is, hey, how can we get more appliances in under a smaller space or a smaller square footage? And I'm just showing some examples here. We happen to rep Navien and iFlow, and this could be anybody's. On the right-hand side, there's a Renai with an air handler there as well. But essentially what we've done as manufacturers, or we've fed the information to the manufacturers, we need smaller packages. And so here you can see that we can develop a mechanical room that fits in 8.5 square feet of floor surface. So it's there. The technologies are there for us to sort of deliver the goods with respect to the small footprint. So we can deliver the BTUs you need in a very small footprint. And the way we lay things out, it makes it easy for us to access, to get maintenance done or anything that we need to do with respect to servicing the equipment.
And of course, those combo systems are servicing both the hot water and the space heating.
In this case, thank you for that. Yes, in this case, what we have is one appliance that's doing both domestic hot water and space heating. And so if we think about, earlier we were talking about penetrations and how far apart everything needs to be. One of the big goals is, the least amount of penetrations we have in the wall, the better. And so this allows us to take, in effect, where we had 2 sets of penetrations, now we have just 1.
Thank you.
And then, sorry, go ahead.
No, go ahead.
Well, this to me was this embraces this whole thought process about getting as much in a small space as possible. And here's a job that we did with Lysani Homes a few years ago, maybe 3 or 4 years ago, where we basically put a mechanical room in 3 by 3 foot mechanical closet. And in here you see your domestic hot water appliance, an air handler, air conditioning, and an ERV.
Wow.
So when we start thinking about, this whole challenge we're going to have with respect to secondary suites, excuse me, it's not going to be as big of a challenge maybe as we think. Because, over the years, we've been developing technologies, smaller pieces of equipment. We're very fortunate that our HVAC contractors are very creative, and our building designers, everybody works together. There's a collaboration that takes place, and we try to figure out how to do this the best way. And so for me, this was one that I thought would be very interesting for us to showcase today.
Thank you. And Jason, this obviously is a challenge. You get this all the time too, big house, small mechanical, but tiny home, where do we go? I think you're going to say, at least this is showing it there. You'd also have some options, maybe in that secondary suite, that boiler, that Navien water heater just becomes in-floor as opposed to forced air. But that would have implications on the ventilation design. Is that how counteract? That is,
sorry, what was the question again?
well, if you're going to do both, let's say in-floor heating or radiant heat, then that would change the ventilation design as well, presumably.
Right. There would still need to be ventilation strategy. So we're back to either the prescriptive path with another HRV or ERV, or performance path where we might be able to model it out.
Right. And the ductwork now may just be supply air ductwork as opposed to heated ductwork, but you could do a fully ducted HRV and so on. So lots of options there. So thanks, Strat, for highlighting that. And then I'd mentioned kitchen ventilation, but you want to speak to that just briefly?
Well, again, it's a similar conversation to what we had earlier with respect to the ventilation equipment. This obviously is part of, getting the bad air out of the house. And so there are a lot of options. And one thing about range hoods and exhaust fans, those are typically viewed every single day by the consumer, unlike the HRV. I think for Jason and I, and even you, Gord, the first thing we do when we go into a house is we run down to the mechanical room to check out the mechanical room and see what's in there. Typical homeowner doesn't do that. So there's a full range of different application or different styles of range hoods and various CFMs. And so there's lots to select from.
And minimum 100 is what we mentioned. And
Correct. Yeah. And so we're showing here, in this case, we have a 210 to 650, but that's for the whole range of under cabinet range hoods. We have under cabinet range hoods that are at 100 CFM.
And just being mindful of makeup air. And so we'd have to think about that as well. And then, of course, the good old bath fan's even gone through some really nice changes.
Right. And so here what we have is your good, better, best option with respect to fans. And if you've been in the industry long enough, like we have, you remember the days where the fans really didn't do much. And over the years, they've really done a nice job of improving their airflows and then how quiet they are. And then there's all sorts of options with respect to humidity control, lights, even sound. You can get a bath fan that has a speaker in it now that allows you to enjoy some music while you're taking a shower. The slide here for me was really just important to, again, to say, hey, there's a full range of product here. There's good, better, best. There's all sorts of selection criteria to look at with respect to zones and CFM. But, I'll go back to what you said earlier, Gord, with respect to the bath fan. It has to perform now. And there has to be a CFM at a rated pressure. And that wasn't always the case. And so we're seeing the need for more and more precision, and all the manufacturers, obviously Brown included, is delivering the goods there.
And imagine that secondary suite, you're going to have at least a bathroom and at least a kitchen. So now you got two range hoods potentially, or using fully ducted ERVs. So first, lads, you say, I'm going to need 2 ERVs. Well, maybe not. Maybe that's true, but maybe that helps you. I don't need to put in a second fan. Maybe I can even do an exhaust outlet from the ERV or HRV instead of a range hood. Of course, we would still advocate for a range hood, but it's going to give the range. I like the way you said it. There's a whole range of products. It's going to open up, and the designers like Jason are going to try to be creative and pick the right combinations of balanced ventilation and exhaust only ventilation to meet the needs of, I would say, more complicated houses with higher occupancy levels. So thank you for that. And then I know you wanted to show these really just from a perspective of meeting those low CFM requirements, how the controls help with that.
Yeah, again, it allows us to, I'm going to say overall, what we have is more precision. And so the controls are there to help us monitor the indoor air quality from a humidity standpoint, make sure we don't have excessive humidity. And there are controls available too that monitor outdoor air temperature, which allows us to do a better job of controlling humidity in the house as well. So again, the goal with these central wall controls is to have the ventilation system on, off, or high or low speed, whatever you've selected, but also to help maintain good relative humidities in the house, not get excessive moisture into a home.
And remembering that we have to have that low speed, right, within that range, the new range of airflow. So the controls are going to help you get to that level, which I think you want to speak to with respect to flow verification.
Right. Thank you very much. And so what we have now is a technology, we call it the virtual air technology, but I think the next slide shows us the motors. But these ECM motors are electronically commutated and so on. But essentially what we have is we have brains inside of each of the motors. And we can get feedback from the motor that tells us what the RPM is, what the amp draw is, and we can calibrate a system to use that information to dictate what the CFM is going to be. And so what virtual technology does is essentially you plug the unit in, it ramps up and it tests, and it looks to see how much airflow it can move in the exhaust air and in the supply air, and then tells you what the maximum is. So for example, if it can do 140 CFM of exhaust and only 130 CFM of supply, it'll show you that the maximum CFM you can have on this system is 130 CFM. And then if you have, if Jason has done the design and you need only 120 CFM, you can use the toggle switch to dial it down to 120 and hit enter, and then its high speed is set at 120. By default, it selects the low speed at 50% of that. So at 120 or 110, it'll be 55 or 60 CFM. But you also have the option to lower the CFM. In this case, we're showing 35, but you can lower it to what you want. And once you've done that, the next thing it'll ask you to do is to talk about the type of installation that you have. Is it a fully ducted system? Is it simplified, exhaust ducted, whatever it is? You program that into it and you're done. So a process that used to take the balancing of the equipment, that used to take, say, 20 minutes, half an hour, is now a 5-minute job. But not only is it balanced, but you have flow verification. So it's important. We'll go back to this whole thing about precision. The inspector can now walk into the house, look at the digital display, and know right away what the high speed and the low speed are on the system. So it allows us to do that, you know, deliver the precision that's required in these types of applications.
And thanks for that. I'm smiling because you said 20 minutes. You're talking to a guy who 40 years ago, we had to do hot wire traverses in every duct. So 6 readings, average
Yes.
them out, 6 readings, dust the depth, 6 readings. So yes, so I'm very pleased to see this, and all the leading manufacturers are heading towards this level of precision.
Yes.
So thank you for that. I know you wanted to highlight where we'll watch our time just a little bit.
Yeah, okay. So this is just real quick about the blower motors. These things are very durable, not a lot of vibrations. So now you can actually directly mount equipment to a wall, whereas before we had to hang it, we had springs and such. These motors are very smooth, and so you can hang equipment on the wall. The other thing about the motor is again, I talked about it knows what the RPMs, what it's spinning at and so on. So if and when I decide to go to a higher efficiency filter, the motor takes that into account and ramps up to get us to where we need to be with respect to our airflows. And these motors allow for constant RPM, or constant balancing. So as filters load up, the motor is always adjusting the airflows to ensure that we're balanced. Yeah.
And that full range, and I always like to say, when you're choosing a ventilation device, first choose balance, second choose the core technology, HRV or ERV. Next, think about the blower capacity and airflow and efficiency. And then by all means, let's talk filtration. We said it was MERV 6 is now minimum.
So these are standard MERV 8.
Yeah.
And we have an option for a 13 or a HEPA.
And MERV 13, because in California, that's the minimum requirement for fresh air intakes, MERV 13. So pretty powerful. And that Strat, we always get asked, are we going HRV or ERV?
So the short answer is just go ERV.
Yeah.
ERVs are going to transfer moisture. I think most of the group that is on our call today has heard the differences, but essentially the messaging is this. ERVs are capable of giving us more stable relative humidities in a house. So in the wintertime, the house doesn't dry out as quickly. And in the summertime, we're not stacking humidity. We're not bringing in that warm, moist air from outside or hot, humid air from outside. And so you end up with more stable relative humidities with ERVs.
And the time was ERVs didn't work in Canada. There are still some ERVs that wouldn't work in cold climate. That's why you want to see that -25 number.
Correct.
So products used in Canada have to see that -25. In BC, you're allowed to show lower mainland. Your design temperatures aren't that low. So, but you might be able to use equipment that's not rated at -25. But for the rest of us, you need that device, that design temperature showing that at least it could ventilate. Less worried about its efficiency, but at least that's a ventilator. So if you're going to bring an ERV from somewhere else, make sure it has a low temperature ventilation reduction factor of within that 50% requirement. So we'll keep that in mind. And then I had mentioned that flex duct, or the insulation was not as big a deal level, but you wanted to also just highlight quickly before we get to
practice, right? It's good practice. And so our goal is always for the builder, for the heating contractor is provide the information that's going to reduce the callbacks, that we don't have as many callbacks. So when we do ventilation training, we talk about Flex Duct 101. What is a duct and what is a connector? So all the manufacturers have either an air duct or an air connector. And our message to the HVAC contractor is always try to use air duct. It's more durable. It allows you to connect longer than 14 feet with respect to the length of the flex duct. and you just end up with a better quality product and better installations.
And as a designer, is that on your radar, Jason, that you would specify air duct for if you see that let's say the HRV is more than 14 feet away? Are the two labels? Because this is in fact the shape of the label on the duct. A round is a connector, a square or rectangular label is a duct. Is that on the radar of most designers, most contractors, Jason?
I couldn't tell you.
It is interesting though, isn't it? Because in theory, and you could put in connector, run it 20 feet, and the local inspector may come along and go, actually, that doesn't meet requirements. Because this is code requirement.
Yeah, and we've all had, stories where that was in fact the case, and it was a big development, and there was, 50 or 60 installations that had to get changed. So
right. So be mindful of the labels on the ducts. And then I mentioned, Strat, that this is the table that was in the interior building code.
Right.
It's still in the F326, but it's no longer in the new interior building code or the national building code.
Yeah. Yeah. So most of the installations that we see, guys are using an R4.2 for most of the installations. We have talked about to people about, hey, when your outdoor design temperature is colder than minus 12, you're going to need to go up a better R value with respect to your duct. So again, now this isn't so much from a code perspective. This again is good practice.
Right.
So reduce callbacks and so on. It's a few extra dollars to put in better duct, more insulation, but it's good practice. So something to be aware of.
So R4.2 is pretty standard. R6 and R8 are pretty standard.
Yeah.
There's no such thing that I know of as an R10. You'd have to insulate it differently. But just be mindful of, folks, that this is maybe gets you out of a risk factor because you probably weren't following this anyway. But it's no longer in the interior building code is the point. It is in the F326 requirement. And I don't know if we need to speak to that one or not.
No.
Only to say that there is a group, the Air Diffusion Council, that regulates the ratings on ductwork. Good. And so we're about ready for questions. I just wanted to show a summary slide. So the new National Building Code 2020 and the Interior Building Code 2024, they appear to have much different wording than OBC 2012. However, they're both based on the principles outlined in F326. So in terms of practical applications, you're not going to see much difference. Some nuances, but not much differences. And HVAC designers will find that their current design choices are pretty much applicable with some minor adjustments and enhancements. And if needed, as Jason mentioned, submit your ventilation designs using F326 referenced in Part 6 of the code. So we're in pretty good shape. I hate to say you've spent an hour or 75 minutes and we're telling you don't have to make any changes. That wasn't the intent, but it should be good news to say ventilation is still important. We've enhanced our understanding of ventilation, better filtration, better distribution of air, better exhaust from kitchens without a lot of cost upgrade. And in some cases, maybe an opportunity for optimizing using the new F326 standards and some of the new equipment that's out there. And Strat, I know you represent specific brands, but you would say all of the leading manufacturers, at least all the ones that are HVI labeled. I put in a pitch for HVI, Home Ventilating Institute. Everything that you put in needs to be HVI. But I think you'd agree all the manufacturers are doing an excellent job these days.
Absolutely. Yeah. Yep.
So good. Let's stop there. And we are perfect timing for questions. So we have about 12 minutes left for questions. I see lots of stuff in the chat, but are there questions? Any actual questions?
There's a few in the question and answer window, Gord, asking about ventilation capacity. If you have a standard home, but with more occupants, or a large home with very few bedrooms. I was wondering if we would address that first. So the first question is, what happens to ventilation design requirement-wise if it's a 3-bedroom home with, say, 10 to 12 occupants in the house, such as the case for some First Nation homes based on code?
Yeah. It's a really good point, isn't it? The National Building Code doesn't speak to that. Certainly F326 does. F326 says, as a designer, if you know there's going to be more than one person in bedroom, then you should design appropriately. And the nice part is F326 is really clear. It's 15 cubic feet per minute per person, which is the same that your kids' classrooms are ventilated at. So if you knew there was going to be 10 people, 10 times 15 equals 150 CFM of ventilation. And Strat, you would say, still got you covered. We're okay with that. But Claude, I certainly understand and have seen your challenges. So be mindful of it, design accordingly for sure. And then I see the next one. If you have a large home with 2 bedrooms, what do you recommend if you want to size the ERV, HRV to the total ventilation capacity? Jason, your thoughts when you get to those larger houses?
What I would do is I would look to I'd look to the ASHRAE standard. So ASHRAE has a slightly different equation for determining ventilation capacity in a home, where it takes number of people into account, but it also takes the house volume into account. The CFM rates that we've seen in the building code so far come from an assumption of 1 person per bedroom, with 2 people being in the master bedroom. So that's where the whole bedroom count equals principal vent capacity comes from. But in a case where the home is fairly large, a large volume home with 1 or 2 bedrooms, it may be more beneficial to go the ASHRAE route, which is still considered good engineering practice under Part 6. It may involve having to consult with an ASHRAE engineer, though.
And thank you for that. So yes, ASHRAE takes into account square footage / volume of the house in addition to the number of bedrooms. And I think, Jason, you're probably saying you're also going to look at the kitchen exhaust and bathroom exhaust. You probably get more than enough capacity out of your supplementals than worrying too much about the principal amount. It might be more about the exhaust amounts. Thank you for that. Curtis is asking, will the intake exhaust distance affect tandem hood ratings? That's an interesting one. And the short answer is no. Typically, you would end up going under F326. And in F326, it specifically talks about concentric hoods and being allowed. And so you would call that up. There is going to be a burden on your representative of those tandem hoods to make the case to the local building officials that the testing's been done. Strat, any thoughts on that?
These are hoops we've all jumped through, right?
Yeah.
We've had lots of conversations with building officials, and it boils down to the cross-contamination.
Right.
So if I can give you a tandem hood or a concentric hood that has very low cross-contamination, then we've achieved our goal.
Right.
It helps us in the multi-res applications where the back end of the house gets really busy. And it's tough sometimes to find the 6 feet now that we need. So the short answer is yes, we've jumped through these hoops. We can help the contractor or the building official with the information. It's cross-contamination. And then the other limiting factor, of course, is airflow. So let's just be aware that the airflow with tandem hoods is limited to around 110 CFM. Yeah.
And I will say there is supporting documentation, both from F326 that mentions specifically concentric hoods, and then there's a calculation under ASHRAE 62.2 that shows you how to do a calculation. So you're in good shape. The next question was, and I'm not sure I can answer this one, is there a compliance alternative in Part 11 for existing houses that are doing duplex conversions regarding the 933, the heating requirements for separate suites? And I
can speak to that a bit.
Thank you.
So one, I did see that question come up, so I started looking in Part 11 for a possible answer. And then as I was doing that, someone in the chat, Patrick Andres, did post pretty much exactly what I found. But essentially, there is a compliance alternative for, I'm just going to pull up the code clause here and read it here. So there is a compliance alternative. It's labeled C200, and it applies to 933.11. So the alternative reads, in a building containing not more than 4 dwelling units, the existing heating or air conditioning system may be altered to serve more than 1 dwelling unit, provided smoke alarms are installed in each dwelling unit and provided a smoke detector is installed in the supply or return air duct system serving the entire building, which would turn off the fuel supply and electrical power to the heating system upon activation of such a detector. So a short answer, yes, there is a compliance alternative, and that's it.
Good, thank you. And then Ali's asking, considering the change at F326, do you think we can still follow the residential ventilation, HRAI's residential ventilation manual? And the short answer there is it's being rewritten. There's a committee that's just been struck on that. So it's expected to be updated very shortly. So Ali, watch for that. And so the short answer would be, yeah, continue using it, but it's going to get modified. So we want to speak to that. Steve's asking, can you use flexible ducts for fully ducted HRVs and ERVs? The code would suggest yes, as long as they are class 1 ducts, so air ducts as opposed to air connectors. So you would be allowed, because it's a ventilation, serving ventilation only, as opposed to heating, you're in good shape. So you can use fully ducted. You can actually use fully ducted, flex duct on heating systems too, under certain circumstances. So there is an opportunity if you're using a class 1 duct. That I did my own house that way, and it neatly fell into code as long as you're using a class 1 rated. And Strat, I don't know if you want to speak to that, but that's back to that Air Diffusion Council.
Yeah, all the information's on that document. So if you can go to thermoflex.net and you can research that and have a look at that document.
And then David, I think, is asking the same question. Jason, I think you'd agree that that's back to Part 11 requirements.
Okay. So again, so that compliance alternative clause, for those that wanted to note it, was C200, referring to 933.11.
Right. Ali's asking a second question. I don't know if that's allowed. Is he allowed 2 questions? Oh, I don't know, Ali.
We'll give it to him.
It's
We're breaking rules. We're breaking rules.
And so his question, in a house with 2 dwelling units and a total of 5 bedrooms, can we use OBC 932? And the answer would be yes, because it's under 5 bedrooms. I think the more interesting question would be if you have 2 dwelling units at more than 5 bedrooms, because then it would say got to be Part 6, or do we look at each of those dwelling units individually, which I think is a very interesting question. It has come up already from a building official, Jason, you may recall, who wanted a stamped drawing. So one, it doesn't have to be stamped, because you're just going to Part 6, which says F326, and there's no requirement to have an engineer design that, as long as you're using F326. And your decisions wouldn't be that much different, but you probably would revert to an F326 design as opposed to a 932 design. So that would be interesting. And then Brad is asking the question, can second floor bath exhaust still exit via soffits? And the answer would be yes, as long as the soffits are blocked in accordance with for prescribed distance, in accordance with what Jason had mentioned before. There's a pretty nice table, kind of shows a pyramid actually of how much that soffit has to be blocked. There's a really cool, well, in fact, I know of 2 really nice soffit vents that I would stack up against hoods up on roofs. I'd almost rather you go through the soffit. Panasonic has one, I think it's called EZ Vent. I think it's called EZ Vent. I've used it. It's really easy to install. The group out in BC, I'm going to forget their name. I always forget their name. Strat, you may recall them. They've got a really nice soffit vent for both range hoods and.
Does it start with a P?
I can't remember.
Is it Primax?
Primax, yes, thank you.
Okay.
Yeah.
All right.
Really good soffit vents. I love both of them, but you would have to ensure that the soffits to either side of that vent would have to be non-vented soffits.
Yeah, it's good product.
I can't imagine.
Sorry, Gord, just wanted to interrupt. For those who wanted to look up this table for
Yes.
requirements of blocked soffit lengths, in the 2024 OBC, it's table 932.313A. And that covers, like I said, blocked soffit requirements.
Right. And then I do have to show, sorry. I know we're almost at time. We're right at 2:30, but I'm going to show this. We have just 2 slides to show. which is stay tuned for our series for next year. And again, if you have suggestions for sessions, we're happy to do it. And even if you want to be a speaker and you have a suggestion for a session, by all means, let us know. And then just to remind you of our newsletter, and we'd love you to sign up for that. And I'll show you the slide to get to that, or at least our links on our social network. And I just want to take this opportunity again to thank Michelle. I still think it's so cool that here's an organization that's constantly supporting. And as you said, Michelle, even when they're not building gas housing, we're still helping the industry, which is very cool of you. So I'll just say thanks once again for supporting this series. We've enjoyed it throughout the year. I'll say thank you to Strat and Jason as well for being on side.
Thank you. Yeah, for the opportunity. It was a lot of fun.
Right. And by all means, work with the manufacturers. I think it's fair to say the ventilation manufacturers, the heating manufacturers are aware of these changes and would love to help you through this. And just, I'll take this opportunity to say, because I'm not on the next one, but a Merry Christmas, the best of to all of everybody in the holiday season, and be happy, be safe. I've got 6 grandchildren now to spend time with, and hopefully all of you will have the same joy that I will have spending with my kids, my new grandkids. So please enjoy the family time in the coming weeks. Thank you all.
Thanks, Gord. Thanks, everybody.
Thanks. Bye, everyone.